Hey everyone, this video is going to be on CNC lathe programming of drilling and boring using the TL lathes in our shop. You can find drilling information in between pages 116 and 118. They're the same codes as the mill, with G80 being can cycle cancel, G81 being a drilling can cycle, and G83 with a Peck drilling can cycle. We need to make sure that we'll be on location for drilling, which would be X 0.0, and normally about 100 thou in front of the workpiece. The setup of the machine is going to be extremely important. We need to make sure the tool post is square to the machine, and we can use a coaxial indicator in the chuck to sweep the collet tool holder in the tool post. We'll be sweeping the tapered surface, and we can accomplish setting up X00 by adjusting the tool holder's height and hand jogging in the X-axis. Once sweeping the tool holder and getting 0 all around, we'll hit X diameter measure on the controller and enter 0, 0 for the diameter. We need to be on the center line of the part, and this needs to be done with all drilling tools. This includes spot drilling and drilling. Now let's take an example at the first line of code. This is going to be for spot drilling. You can see that I turn the spindle on, I wrap it to a safe X location, and then I go to Z.1, and then I just call up the G81, going down to a depth of -50 thou with a retract to 0.1 with a feed rate of 3 thou per revolution. For the next line of code, I'm going to be Peck drilling with a 1/2 inch drill. You can see the beginning of the code looks fairly similar to spot drill, and then I get to G83. I have a different depth, and then I have a Q value in for my pecking and a different feed rate value. Now let's check out this code on our Haas simulator. You'll see that I have 2 tools in there. I have all the code written up in MDI, and I'll go through showing in graphics, and then I will run the MDI program as if the machine were running and it was actually cutting something. Now that we've used drilling to create some holes, we're going to be using our boring bars. When programming boring, we're going to use G41 for tool nose compensation left. For the setup and the controller, we're going to use tip 2 in your offsets page. This is on page 63 of our text. Your stock definition in your line of code will come from the X and Z callout before your G71 can cycle. It's very important that the U value in your G71 line is negative. We want the diameter to be smaller when we're boring. Taking a look at the example of code on the next slide. When using tool nose compensation while boring, it's very important to know your final diameter and your beginning diameter. If the departure move is too small, you could result in a tool nose compensation error. The last thing that I want to make you guys aware of is you need to know the size of your boring bar and the starting hole that you're going to be entering. In the Haas lathe machines, setting 287 is the can cycle retract. The default setting is 0.1. If you're using a boring bar that's close to the diameter that you're entering, that retract could allow you to hit the wall on a retract rapid back to its starting position. I recommend reducing this to 10 to 30 thou depending on your specific situation. This next slide is a print of the boring ring project you guys will be working on in lab. Following up will be my program running on the simulator. Notice how I have tools 1 through 4 set up with a spot drill and a drill. And I'll also go through the tool settings to show you how I set up my tooltip orientation and then show you what the boring looks like in graphics. Take notice here how the G81 and G83 code look very similar to using them on the mill. And also take a look at my roughing cycle for my boring bar and how one of my values is negative.